కంట్రోల్స్ వస్తున్నాయా నీకు?
యా ఉన్నాయి నా దగ్గర.
ఓకే. డన్. ఈ స్ట్రీమ్ లింక్ దీంట్లో డ్రాప్ చేస్తున్నాం ఇంకా పార్టిసిపెంట్స్ గ్రూప్లో.
యూట్యూబ్ లింక్ డ్రాప్ చేయనా నేను?
స్ట్రీమ్ యార్డ్ లింక్ డ్రాప్ చేయరా? స్ట్రీమ్ యార్డ్లో వస్తారు కదా.
ఏంటది?
స్ట్రీమ్ యార్డ్ లింకే డ్రాప్ చేస్తున్నా అంటున్నా.
స్ట్రీమ్ యార్డ్ లింక్ కాదు, యూట్యూబ్ లింక్ డ్రాప్ చెయ్యి.
షూరా?
యా.
ఓకే డన్.
అన్న స్ట్రీమ్ యార్డ్ లింక్ చేయమన్నాడా? స్ట్రీమ్ యార్డ్ కొడితే నువ్వు ఎడిట్
లేదు,
యాక్సెస్ అంతా వస్తుంది వాళ్ళకి. ఏమో నాకు
లేదు.
తెలియదు.
అది నాకు చెప్పలేదు. ఐ మీన్ ఏ లింక్ డ్రాప్ చేయాలో చెప్పలేదు నాకు కూడా. ఒక పని చేయి,
యూట్యూబ్
ఇదే డ్రాప్
యూట్యూబ్
చేయి
లింక్
మరి.
డ్రాప్ చేయి.
యూట్యూబ్ లింక్ నువ్వు డ్రాప్ చేసారా? డ్రాప్
యా
చేసి
షూర్.
ఆస్క్ పీపుల్ టు జాయిన్.
ఓకే డన్.
ఓకే.
యా.
మ్మ్.
అక్కడ ల్యాగ్లు ఉందిరా అది.
డ్రాప్ చేసావా? ఓకే.
కానీ చేశారా?
ఓకే రా.
డన్.
Hello everyone. You can also call your friends who have registered for the session. We'll be starting in 5 minutes. Hello, guys. Hi, good afternoon. It's almost about to be good evening in the next 8 minutes. Am I audible, guys? If I am, you could just drop a chat. We have a chat section open for everyone, so you can just drop in a text over there if I'm audible. Okay, that's great. We have a few responses, we have active people. So, this is the day 2 of Local Hack Week Season 2, and the session that we're going to look into today is AI agents. So basically, this session is going to be a small glimpse of about AI agents. You'll understand what AI agents are actually and how they work. How do you think you can leverage them, understand them, help them? Use them to build into your applications and make your life easier. So to begin with AI agents, what exactly do you think AI agents are? Do you guys have you heard of AI agents anytime before? Okay, well, we don't have responses, but that's okay. So, if we look into AI agents are nothing but they are agents that you built with the help of a model. Basically, the brain of an agent is your AI model. You wrap an agent around a model so that you can specify it and customize it to do a specific kind of task. For example, you have a model, let's just say an Anthropic model or an OpenAI model. You just have a bunch of queries that you ask to the model, but it gives you an output. But then you want your output to be customized in such a way that you have a very peculiar set of things that you want your model to give you. And those kind of things are not something that your model gives. So what do you do instead? You wrap an agent around the model so that you get a response only customized to your preference, giving you what you actually want. The end of passive responder. Like I said, LLM are pretty good. They are very large language models. But then if you really look into it, LLMs are not something that can be customized that easily. But agents can be customized. Because the main core architecture brain of your agent is your LLM. So you're just leveraging the LLM, building a layer on top of it, something that you can customize and use for your own purpose with your own customizations. LLM is a passive responder, generates output strictly based on immediate user prompts, ops on static function, like it says. But if you look into an AI agent, it independently initiates actions, maintains persistent memory across interactions, and manipulates external systems to achieve human-defined objectives. Like I said, your agent is much more and far more capable than an LLM. But then, if you really think about it, your LLM is the core brain of your agent. So both of them are equally important. But then a few of them have doubts regarding these AI agents. They think AI agents, chatbots, automations, all these kind of things are similar. But then if you actually look into the core architecture of these foundational models, they're completely different. If you look at an automation is basically a sequence of steps that you automate so that it can perform a task. But then if you look into a chatbot, all of these have the core AI model that is an LLM as its brain, but then their functionality is completely different. If you look at a chatbot simply takes in a prompt and generates a text. There is nothing a chatbot does other than this. But then if you look at AI agents and automations are kind of similar, but they're not exactly same. So AI agent will also automate your task. You give it a sequence of steps, it will execute it. But the difference between your AI agent and your automation is that your AI agent runs in an agentic loop, a loop that runs in an iteration that keeps improving your agent over time with every loop that it takes, so that the output you get is the best and most optimized output other than an automation. The same does not apply with automation because automation is just only a sequence of steps. It does not involve in a loop, or it does not keep self-improving itself for you to give for I mean to give you a better output. Now, what exactly is the core autonomy of an agent? The core autonomy of an agent is split into five parts. The first part is the perception, converts raw environmental inputs into structural tokens. Let's just say you have all these texts, API responses, logs, all these different kinds of data. All the data that you create, all the data that you want to feed your agent should be converted into raw environmental inputs that will be changed into structured tokens and fed to the model, fed to the agent. And the second part of your agent is the planning part. That is the brain, the LLM reasoning engine that formulates step by step strategies. Like I said, their core architecture, the core model of the core brain of your agent is your LLM. Without the LLM, you cannot run your agent. If you look at the third main anatomy of the agent, it's the memory, maintains context and semantic history. So memory is something that plays a crucial role in your agent. Your agent cannot take indefinite data. Let's just say you have a PDF that consists of 1,000 pages. You cannot feed your agent the entire 1,000 pages and expect it to remember because the agent memory is divided into two parts. It is short memory and long memory. Short term, that is short term memory is changed is called as context window. Context window is just a part of memory where it retains only a very few fragmental part of information that only the agent can see at a time. That is short-term memory. But then if you look at the long-term memory of an agent, that is known as vector database, where your further entire data that you want to feed to the agent will be converted into embeddings and stayed in the form of a vector database which can be retrieved via queries using RAG. That is something that helps you to understand the core architecture of an agent. Now, these kind of things might sound complex to you, but if you actually look into the core aspects, it is very much simple because your agent is very simple to understand. It has perception, it has planning, it has memory, it needs tools, and then it executes the action. Now, your fourth main integral part of the anatomy of an agent are the tools. Now, unlike automations and unlike other chatbots, your agent has the ability to take access of other external tools and perform a task. Let's just say I have an agent. I want it to generate a text and then create a Word file to save the text. Now, an automation or a chatbot is not capable of doing such kind of things, but an agent is capable because agent will have access to these tools which can help the agent to create any kind of document or structured output that you want it to give you. Now, the fifth main core anatomy of an agent is action, the execution layer that carries out decisions and captures the resulting observations. Now, if you see clearly, your agent has taken your information, has processed it to an LLM, has saved it in the memory, has applied tools to get you an output, and the final aim is to give you that output. And that output is executing the so called action. Now, what exactly does your loop does? Like I said, unlike your automation, AI agent runs in a loop. This loop consists of few main parts like action, observing, and planning. Now, this is a recursive loop that keeps happening in an iteration over and over again until your agent gives you the final and most efficient output that you'd want it to give. The next thing that we're going to look into is the memory of an agent. It is the context window. Like I said, context window is a very small fragment of the memory that the agent looks at. Let's just say you have 1,000 pages of a document. But then if you feed 1,000 pages to your model cannot see all the 1,000 pages at once. But a portion or a fragment of that document can be seen by your agent in the context window. Like let's just say 10% of it, around 100 pages or something. Just a rough estimation. So in order for you to understand the memory of the agent, it is very important for you to understand the context window. Now, this is also a bottleneck because you cannot feed your agent indefinite amounts of data at a time. You only have a very small window to feed in. But then does it mean that your agent cannot store other data? It doesn't mean that because we have vector database. Like I've explained it before, vector databases is a database where your entire text that you want to feed your agent will be converted into embeddings and stored in the form of a database which can be retrieved via queries, which is also known as RAG, retrieval augmented generation. This helps you to actually retrieve the data that you saved in a vector database. Now, the saving of all the information in the database of the vector is a little complex topic, but all I want you to understand is that the amount of data that you want to feed in your vector database will be converted into embeddings. Now, what is MCP? Model Context Protocol. Let's just say, like I said, you have automations, you have chatbots, but they do not have this ability to talk to other tools and use those tools to generate other information, like generating a document, like generating a PDF, or anything of that sort. Now, that is where MCP comes into the picture. Now, the language of our agents and the language of these tools are completely different. But how do you think they can communicate with each other? Your model context protocol comes into the picture where your model context protocol communicates between your agent and the external tools and helps to bridge a barrier between them so that your agent can leverage those tools and build applications or generate documents or generate PDFs or generate workflows, anything of that sort. And if you want to look at this further, we can see the multi-agent orchestration topologies, which means your AI agent can be arranged in different layers like supervisor worker, peer to peer, hierarchical multi level. Now, these are different kinds of orchestrations that you can apply to an AI agent so that it can work more efficiently. Now, these are a few frameworks that you can use to create an agent like LangGraph, QI, AutoGPT. These are some of the architectures which are already pre-built. We can download these kind of architectures and customize them for our use so that we can get a better understanding of what we're trying to build. Now, with all the information that we've taken, now let's look into a practical demonstration of how do we actually do it. I hope my screen is visible to everyone. Guys, can you please drop in a text in the chat if my screen is visible? Okay, that's cool. Now, this is a custom agent that I have built. So basically, this is something like, yeah, I hope all of you know about DSA, right? Yesterday we had a session about competitive programming, DSA, all these kind of things. So this is an agent that I have built. So my agent uses Gemini as its LLM, which is its core brain. Now this is the agent that I am using so that I can solve DSA questions. Now, if you've ever tried to, generate a solution for a DSA question, you know that every question that you generate in DSA will be checked via plagiarism, so that just to see if it is AI generated or human generated. So, in order to tackle that, I have built this AI agent. So, what my AI agent does is, if I just give it a question, it is going to analyze the question and then create an output. The output is very well curated and it is curated in such a way that it cannot be, even if you try to check a plagiarism on it, you wouldn't detect it because the agent has curated the solution in such a way that it can bypass all these plagiarism. For example, If I ask it a question, now I will explain you the entire architecture of this agent, but then let's look at the demonstration. You see, I've given it a question, and the question is, given an array of integer sum and an integer target, return indices of two numbers such that they add up to the target. Assume exactly one solution exists, and you may not use the same element twice. Write the optimist Python solution. Now, if I try to run the script, your agent is doing its work in the background. Let's see how long it's going to take to generate the solution. We already have a solution here that has been generated in my previous response. Like you can see, this is the solution that the AI generated. This is the agent solution that my agent generated. You see, it generated the solution. Defined to some AT, it created a dictionary and then created a loop and added a conditional statement. So this is basically the solution which my agent gave me in order to bypass in order to bypass the plagiarism. Now, if I copy the same question and give it to an agent, let's just say Copilot. Let us give it the same question and see how an LLM responds to this. Mm-hmm. Define to some target scene for I. It has also generated a similar kind of solution. But if you look at it, I know the difference is not because of the models. The difference is because of how you have written, customized your agent. You see, the variables that the agent has generated is completely different from what the variables that is generated by an LLM. It is using mnemonics. It is not using any extra spaces. It is not using anything extra so that it is going to look like a human written as a human has written the solution. This is something that my agent is doing. Now, if we look at the core architecture, I am using LangChain as an agent here. My LangChain is a core architecture that I'm using here. Now, this is where I enter my sample environment variables. My environment variable is the Gemini model along with the API key that I'm using. And then this is the system prompt. This is the prompt that I've given to my agent. That is, you are a competitive programming assistant, generate only final answer for the given DSA question. Do not add explanations, headings, bullets, markdown fences, or any extra text. Write human style code that looks natural and clean. Perfectly optimized, use built-in Python libraries, keep variable name short, mnemonics. You see, my agent that gave me the solution has followed all these rules, and that is how I customized my solution. And these are the lines that help me to manage, all the other queries and stuff. These are just pretty normal basic things to handle out your response. My Gemini API keys. Now, this is a very basic agent. These are the requirements. We need LangChain, we need LangChain community, we need LangChain core, LangChain, Google Gen AI, Python dot environment, Wikipedia, DuckDuckGo. These are the search engines that we've used in the question, and these are the architecture of the agent, and this is the Python environment. Like how we just saw a practical demonstration, the core architecture of my thing is all about Gemini. The Gemini is the main brain, and the text that is generated is the solution is not just optimized, but it is also humanized so that the plagiarism cannot be detected. Now, this is how I custom purposed my AI agent. Similarly, you can create your own AI agents and customize them to give you such a curated output so that it serves your purpose. If you have any questions, you can always ask me because the chat is open for everyone. Do you have any question, people? Well, I don't think people are having any questions about this. So far, did you guys understand anything about agents? Do you have any doubts? Well, I don't think nobody has any doubts. Okay, guys, we'll just be back. We have an interesting session coming up. That is, the ones who attended yesterday, they will have an idea of what we'll be doing right now. So stay tuned for it, guys.
Hey there, people. I guess you're having fun in the AI agents session. In case you have any doubts, feel free to drop in the chat. Even I am available. I'm Aditya. I'll also be answering any of your doubts you post over here. So yeah, So I guess that's it for today's session. Like, in case you are interested in solving any of the challenges today, right now, you can just drop them in chat. Hi Soumit, welcome back.
Hi Aditya. Well, we have people here, so let's see if they have any questions. Guys, do you have any questions? Okay, guys. Well, now that we've looked into how agents actually work, let's just get to dive deeper into what are actually problems and what else we can learn about agents. So, if you dive deep in, we can also see that there are some drawbacks and there are some semantic threats to an agent. We have some security threats like blind spot, prompt injection, hallucination cascades, and infinite loops. Now, these kind of things are something that are actually a problem when you're trying to build an agent. Imagine the blind spot problem is traditional enterprise security cannot detect threats operating at the semantical language layer. Let's just say you have some network intrusions, malware signatures, or if you have anything that is actually potentially, something malware, something that can, override systems or something like that. Now, if these kind of things attack your agent, they can create a crucial impact on your architecture and your entire agent. Not just these blind spot, that is semantic threats, we also have prompt injection. Like, for example, malicious content embedded in external environments. It hijacks agents' behavior, causing it to exfiltrate data or ignore constraints. Basically, this is like hijacking your agent. Like with the prompt injection, you are just manipulating your agent to give out some sensitive information, sensitive data that is not supposed to be leaked. And this going out is a very bad thing for your agent because your agent is supposed to protect you and make your work easier rather than leaking your data and doing all these kind of things. So this is something that should be taken care of. You should always look into the core security of your AI agent. Make sure that it is properly encrypted and make sure that it does not fall into all these prompt injections and all these hallucinations. Hallucination cascade and infinite loops are also something that should be looked upon, because when an agent generates a plausible but false premise, act on it using a tool, and feeds the resulting error back into its loop, compounding the failure across multi-step pipelines. So basically, it is trying to say that if your agent is trying to do something that with a false information, and if it's trying to keep iterating it, trying to fix it over and over again with false information, it is no longer, it's not just giving you wrong output, but it's trying to break your entire pipeline and trying to infiltrate it and try to, it's like, it's like you are just making, your system is falling apart in a way. So these kind of things are something that you should always look into. Now, if you see, for the governance of these automated systems, human in the loop. Now, building an agent alone is not enough. You should also look at what you're built and how you are monitoring it. And something like this is also very important, so that let's just say you've built an agent and it goes rogue. Who do you think is responsible for building that? So, whatever we build, you should always account for it. You should always look into how your agent is behaving. Human in the loop, HITL. Now, this is something that is very important. Let's just say you have an agent, you have given it access to a payment gateway, and you have let the agent, make decisions on behalf of you to do the payment changes. Now, imagine if there's a hacker who's been trying to do a prompt injection. Because your agent has your payment gateway access, I can inject a prompt into your agent for me to steal all your credentials and all your money from your bank account. Because your agent is having access to a payment gateway, so it can do that for me. Now, this is something that is why you should always look into what you're doing with your agent. Keeping human in the loop, giving its financial transactions, or giving access to proprietary data to your agent is something that you should always look into. You should be careful about what data that you're giving to your agent. You should be always careful about what access you're giving to your agent. Other than this, you can also look into action list whitelisting, strict cryptographic limitations on specific MCP tools an agent is authorized to invoke. Now, even though you have access to, with the help of MCP servers, you have access to a number of tools. You should always make sure that every tool that you invoke with an MCP server should be looked into. Make sure that everything that you built with your agent and every tool that you access with your MCP server should be apt, and it should be, something that your agent requires and not something that can actually potentially create a havoc, or something that can potentially kick you out of a system or something like that. Decentralized identity, emerging concepts like web3 blockchain to ensure every agent's identity and action ledger is transparent, immutable, and auditable. Now, the identity of an agent is crucial part. Let's just say you have an agent. If you don't give it an identity, the functioning of it is something that can actually drop down drastically, because a study says that an agent with identity works more efficiently than an agent with no identity. So, giving it an identity is not alone enough. You should be able to make sure that the identity that you give to your agent is protected properly. And in order to do that, using technologies like blockchain, Web3, all these kind of things are very important, because these kind of things are something that can help you to encrypt your data properly such that it cannot be accessed by external agencies or potential malware threats. Now, if we look at this, this is the SLM revolution, scaling out, not up. The monolithic bottleneck, powering every agentic step with a frontier LLM, is computationally excessive, higher latency, and financially unsustainable. This is true. Because imagine you have a very large language model. You cannot just use that model to use API calls to power your agent. Doing it over and over excessively is going to cost you API. I mean, for making API calls, of course, is going to cost you a lot of fortune. So, in order for you to tackle that problem, you should make sure that you do not always rely on large LLMs that makes API calls on your behalf. Rather than using large LLMs, you can use small language models, that is SLMs, because small language models are cheaper, they're faster, and they possess low memory footprints. So basically, this is something that can help us to make sure that everything that we are doing with the agents is not going to be, everything that you do with the LLMs is not going to cost a fortune. Now, specialization, because agent tasks are often repetitive, scoped, and non-conversational, highly fine-tuned SLMs can act as specialized tools orchestrated by central planner. Now, this is true because agentic workflow is all about creating an automation and keeping it in a loop. Because this is a repetitive task that needs to be done iteratively. Instead of using an LLM, you can fine tune a small language model in this context and wrap it with an agent so that since your SLM is fine tuned, every output that you get is very well curated to your user requirements. Now, if you see the synthesis of an AI agent, it is a modular Lego architecture. Now, what is Lego? We all know Lego are blocks. Lego blocks, if you construct them together, you can form something out of them. Now, similarly, Legos are blocks that helps you to construct something. Even agentic architecture is all about a set of blocks that combine together to build an agent. Now, if you look at the image, you can see central LLM orchestrator, planning SLM, creative SLM, routing SLM, coding SLM. Now, these are different set of blocks. The memory is the main brain of your agent is the LLM, which is your central LLM orchestrator. Along with this, you also have this planning SLM, creative SLM, routing SLM, coding SLM. They are let's just say, if this is the cerebrum, these are the cerebellum and medulla, which is, an extension of your brain. This brain consists of memory, which is your RAG, which is retriever. If you look at the RAG, it is a shared vector database. Your vector database consists of embeddings. The data that you give is converted into embeddings and stored in your database, which can be further retrieved with queries. And you can also see your entire brain is not alone enough for you to complete your tasks. So in order for you to do that, you invoke standardized MCP tools. Now, these model context protocol tools help you to access tools of other applications, other third-party applications that you can use in your agent. Now, the code of your agent and the internal proprietary codes of these tools are not alike. Now, in order for you to communicate with the external tools, that is where MCP comes into the picture. Now, this acts as a barrier between your core brain and the tools so that you can leverage the usage and advantage of these tools and use them to make your agent better. This is the architecture, like we can see. And if we look from assistance to autonomy, there used to be a time back in 2022 when ChatGPT was launched. Now, back then, all we knew about was chatbots, which can generate outputs based on inputs. Let's just say you ask it a question, it's going to give you an answer. But then we're not in that era anymore because time has evolved from us giving input and getting output to us giving an input and customizing that output as well. Now, this chatbot has been evolved to agentic workforce where we can build our own agentic AI system that can give us a well curated output with the input that we give to it. The core takeaway is that we have crossed the threshold from software that answers questions to software that works. Obviously, you have these tools that we can use. You have everything that you can take, use MCP to call from third parties that can help you to actually build and do something that you want your agent to do. The mandate. Organizations that master agentic architecture, multi-agent orchestration, and semantic governance will not just accelerate productivity, they will fundamentally redefine the structure of digital labor. Now, this is fact. See, understanding the architecture of this agent and multi-agent orchestration is very important because these kind of architectures is something that will come into force in the future, and the productivity is something that will totally be rely on how your architecture is well orchestrated and how your architecture is well organized. They will fundamentally redefine the structure of digital labor. Everything that you do in general will be automated in such a way that let's just say if you have a sequence of steps that you accomplish every day in a task, that will be cut down to your agent doing those tasks for you in a loop repeatedly, recursively, until you want it to be done. Now, with that being said, we have looked at a lot of few aspects in the AI agents. Let us have a quick summary of what we've learned in this today's session. We've learned about an agent. We've learned that agent is just wrapped around a model. It is basically something that you build around a model so that you get something well curated as an output. Let's just say I want something to be in a particular order or in a particular format, in a particular size, with particular specifications, particular preferences. All these kind of things are something that you can do with your agent. Now, like we can see, LLMs are different, our agents are different. LLMs are the core brain part, and your LLMs and your agents are actually the part that works on your behalf using this brain to accomplish the task that you want to achieve. Now, we also talked about the difference between automations, chatbots, and AI agents. Like I said, automations are sequence of steps. Chatbots are just you give input, they gives you an output. But your AI agents are sequence of steps that are kept in loop, in a self-improving loop, so that it keeps iterating itself until it gets the job done. Now, I've also seen the core anatomy of an agent, that is perception, planning, memory, tools, and action. Perception is converting raw environmental inputs into structured tokens. And these tokens are fed to LLM, where your LLM has a context window and a vector database that is looked upon into the memory. The memory maintains the context and semantic history. Once your LLM gets the context, it uses MCP servers to call external tools that it requires to complete its task. External capabilities extending agents' reach. And then we look into the action. Once your agent calls in those tools, it is going to perform the action that you want it to perform. And once that is done, we look at the loop. The loop is the self improving iteration that you do for every agent, because this is what it differentiates from an automation. Because in an automation it is only a few sequence of steps. Let's just say I want my automation to do 5 sequence of steps. It is going to do that 5 steps if everything is correct. If something is incorrect, it's going to break in between. But your agent is not like that. Your agent is a loop that runs. Even though you have only 5 steps, your agent runs iteratively, recursively over and over again until it achieves the task perfectly and until you get the best output possible. Now, the core aspects of these loop are act. The agent formats a syntactically correct tool call to execute a specific function like JSON schema. So basically, The first act of your loop is the first thing, or the first stage of your loop is to act. Once the act layer is invoked, it will go to observe. The agent parses environmental input or the results of the previous action. Once it goes to the observe, it is just going to see what the previous action was like, and is going to see if the action performed in the previous step was correct or not. And once it is done, it goes to the chain of thought, that is the plan section, where the agent is forced to think out loud, generating textual reasoning traces to decompose problems and decide on next step. So this is basically something that you do, that your agent does. It is going to act in the loop, may plan it out. Once it is done with acting, once it's done with observing, it starts planning out its next task. It's going to see what is happening and what is not. And once it is done, you can see that the loop keeps iterating over and over again. The output of the act phrase instantaneously feeds back to the observe phrase, creating a continuous cycle of autonomous self correction until the terminal condition is met. Now, this is the biggest thing that makes a difference between an agent and an automation. Even though you call API tools, I mean, you do API calls in automations, even though even automations use LLMs, this core component of agentic loop is something that differentiates your automation with an AI agent. And next, we also talked about context window. It is the agent's RAM basically. The context window is active scratchpad where immediate instructions, current conversations, and recent tool outputs reside. Now, agent's RAM is a very good word for you to use because, like how we use RAM in your computers, context window is the RAM for agent. This is where your temporary memory is stored, your temp files, like your instructions, your conversation history, everything related, everything that you feed to your model is stored here. But the bottleneck of having a context window is that it is strictly finite. When the volume of observation exceeds its capacity, the agent experiences cognitive overload. Basically, your context window has tokens. Let's just say we have a model that has a context window of 200k total tokens. Now, if you try to give it something that is out of 200k tokens, your model is overloaded, of course. It wouldn't function properly. That is why we will make sure that everything that you give to an agent, everything that you feed to an agent, is within the context window limit. Now, what is the solution to this bottleneck? It requires a perception layer to actively filter, summarize, and prioritize input before they hit the reasoning region. I mean, this is a pretty good option, but is it actually solving your bottleneck? Well, it technically isn't because the technical problem here is your context window is very limited and cannot take more things. What you're basically trying to do here basically you're trying to apply a filter so that everything that you give to your context window is efficient and nothing going there is wasted. But then it's not really exactly trying to come up a way to not to increase the length of context window or something like that. Now, this is something that can be worked upon in future to see if there is a way for us to increase context window and do anything like that. And we also talked about vector databases. We also talked about RAG. Like, if I say context window is the RAM of an agent, vector database is the ROM of the agent, where this stores your entire information that you want your agent to know. This is the long-term memory. Every data that you want your agent to remember is stored in this vector database. The data that you want to give it is first converted into embeddings. Those embeddings are saved in form of databases, and those data can be retrieved using queries, which can be recovered using retrieval augmented generation, which is RAG. We can see the semantic mapping, text to mathematically converted to higher dimensional embedding vectors, retrieval augmented generation. It is basically the instead of keyword matching, the agent performs a similarity search, retrieving conceptually related memories and injecting them into active context window precisely when needed. Well, the search query of retrieval augmented generation is slightly different from how you generally search in a document. In document, if you try to find something, you find it with the help of a keyword. But when it comes to RAG, it's completely different. How RAG does it is that RAG is going to do a similarity search, retrieve conceptually related memories, and then inject them into active context window. Basically, it's going to look at what is similar. It's going to see for look for relevance, and everything that it feels relevant, it will inject that back into context window so that your it will come to your RAM of your agent, where your agent can see what you're actually asking it for. We also learned about MCP tools. Like I said, model context protocol. It acts as a bridge between your AI agent and your external tools, where it helps you to call external tools to your agent so that your agent can perform tasks out of its limitations. Now, this is something your automations cannot do because even if your automations can do, the difference, like I said, comes into the picture, which is the agentic loop. The MCP servers are also not used by chatbots because they are not capable of generating anything out of their capabilities, but your AI agents are. That is why users use MCP so that it can help us to access external tools, which can be further used by the agent to generate things which cannot generally be generated by somebody else. Guys, I think there's a technical problem. Am I visible to everyone? Guys, can you see me? Can I have something in chat?
You just got cut off. Yes. Yeah.
Am I not visible?
Your video is stuck, but you're audible.
I think there is some problem with it. Let me just check with that, guys. Give me a minute. I think I'm back online with the image, with the video. So let's continue. Okay, so now that we've done with our MCP as well, yes, we've also covered multi agent orchestration topologies. So these are basically different kinds of architectures that we use for constructing databases. We have superior worker, a central orchestrated node delegates subtasks to specified worker nodes and aggregates their outputs. So basically here we have a central orchestrator node. So basically this central orchestrator monitors all the other agents which are performing the task and make sure that the output given by them is correct. We also have peer-to-peer collaboration, a decentralized web where agent node communicate directly, negotiating and delegating based on capabilities. So basically, what it does is, unlike a supervised worker, which has a central orchestrator, here we have different types of orchestrators that are connected to each other that are responsible for collaboratively make sure that the task performed by your agent is correct. If you look at the hierarchical multi-level, this has meta orchestrators commanding teams of agents, which in turn orchestrate sub-agents, which means everything that is generated by your sub-agents in an orchestration is also monitored by another central orchestrator so that what you get is filtered through layers and you get the best output possible. We also looked at different kinds of frameworks that exist already. We can see LangGraph, we can see CrewApp, we can see AutoGPT. Now, these are different kinds of agentic frameworks that already exist, which can be downloaded and used by us to build an agent of our own. Let's just say you want to build something related to graph based. You have LangGraph, which is graph based state machine. The architecture itself is graph based. It is best used for complex multiple step workflows requiring branching logic and human in the loop checkpoints. This is pretty good because LangGraphs is something that can actually be used to to solve very complex tasks. But at the same time, even if it is complex, you can also keep a human in loop so that everything that is done by your agent is checked upon every time it is trying to do something out of ordinary. Now, if you look at Crew AI, it is a role-based crew orchestration. Now, what is it best used for? Now, this Crew AI framework is used for collaborative team simulations where agents have distinct personas, goals, and backstories. Now, Crew AI is basically a bunch of agents that are specified in that have specific roles that each agents are specified in their own specific tasks. Now, all these agents come together, combine, work together collaboratively so that you get your desired output. Now, if you look at the framework of AutoGPT, it is simple autonomous loop, rapid prototyping, basic sequential tasks, and such stuff like that. Now, AutoGPT basically helps you to create a very rapid prototype, like a chatbot interface that like how I created, because that gives you just a very normal and basic agent that can be used to get a very well curated output. We also talk about the threats that we will get with all by not keeping your AI agent secure. It is if you don't keep it secure, it is vulnerable to threats like blind spot, like prompt injection, like hallucination cascades and infinite loops. All these kind of things are something that affect your architecture in such a way that they're going to break down your agent into pieces that makes it dysfunctional. And this prompt injection is something that can be used to steal proprietary data and very sensitive information. So always keeping a check on your security of your agent is something that is always very important. And then we also talked about scaling out. I mean, SLM revolution, like always using large language models to make your API calls is be very costly. It's gonna cost you a fortune to keep doing this calls iteratively over and over again. In order for you to overcome that, you rather use an SLM. You take a very small language model, which are cheaper, faster, and they possess low memory footprints. You take these small SLMs, you fine tune them with your specification, and wrap your agent around it so that every task that you perform with this is well optimized for your specification. Because you fine tune your SLM in such a way that instead of using an LLM, you get your own output with the help of this. Now, we've also seen about the Lego architecture of your models. That is, like I said, we have a central LLM orchestrator, we have planning SLM, we have coding SLM, we have routing and creative SLMs. Like how I explained this, if this is the cerebrum, or if your LLM is the cerebrum of your brain, cerebrum of your agent, the planning SLM, the coding, routing, creative SLMs, all these SLMs are like cerebellum and medulla, which altogether constructs your brain of the architecture, brain of your agent. And once your brain is constructed, you connected with a vector database for your long-term memory retention, and then you also connected with some MCDB tools so that you can call in whenever you need and whatever you need so that you can perform a well-curated task which requires a third-party agency. We've also looked at how your chatbots have evolved from normal chatbots to agentic workflows where we don't just give in any input or something. Even if we give an input, you also get a well curated output along with files, along with something else that you want. Because we are living in such an era where you cannot just ask a question and get an answer. You can also make sure that you want to know you can get your answer in the way that you want you to have it. Now that we've also had a small glimpse of everything that we've covered in the session, yep, that is it for the day, guys. We've had a very good brief discussion about your AI agents. We looked at the core architecture, everything else. If you have any doubts, you can always ask us questions. We're open to questions. So, you have any question, people? You can always drop it in the chat box.
Yeah, guys, in case if you have any questions, you can just drop it in the chat. We'll answer it for you.
The chat is open for questions. You can always feel free to answer, ask any questions. We're happy to answer. All right, guys. Then, with that being said, let us conclude today's session. Post session, we'll be having the challenges which will be dropped in the WhatsApp communities. You can have a check. You can just work on them if you want to gain your XP and be on the leaderboard. And if you have any other queries, you can always feel free to reach out to us. The chat is open. You can always reach out to us personally or in this local hack week during this entire session. If you have any doubts, any questions, any queries, feel free to reach out to us, guys. With that being said, let us meet again in the later on session, which will be announced pretty soon. Let's meet in session 2, guys. Bye bye.
Hope you had fun. See you on today's next session. Bye bye.